Dear students, in this experiment we will study about CMOS inverter. CMOS, which stands for complementary metal oxide semiconductor. It is made up of two MOS transistors, in which one is of P type and the second one is of N type. So as you can see, two LEDs are glowing in complementary fashion. So one is input and another one is output. So we will study about it in detail, and we will make a table, input voltage versus output voltage. So this is the circuit of CMOS inverter. This one is PMOS and this one is NMOS. And as you already know how the PMOS and NMOS works. So in PMOS, when we give positive gate voltage more than threshold voltage, I mean maybe 5 volt, so this will be in off state. And this NMOS, if you give 5 volt here, so it will be in on state because the channel will be formed. And when you connect it to the 5 volt, like in this, so this transistor will be working and the LED will be connected to the ground, so the output will be 0. So when I give 5 volt, I get 0 volt here. And when I connect it to the ground, so this PMOS will be working because the P type holes channel will be formed here, and this NMOS will be in off state. So when I give 0 volt here, so this PMOS will be working, and this will be the 5 volt will be connected here through the PMOS, so it will be glowing. So it will be like you give 0 volt and you get 5 volt, so it is like complementary fashion. So you give one means any 5 voltage or any positive voltage, so you will get 0, and if you give 0, and you will get logic 1. So to make a CMOS inverter, I mean to make this circuit on breadboard, we need NMOS and PMOS, which looks something like this. So these are the pins of this NMOS. This is an NMOS I'm showing you. So the pins are like, this one is gate, drain and source. So this one is gate, this one is drain, and this one is source. You can interchange it, as you know, you can use drain as source and source as drain, and this one is gate. So this is the circuit made already for CMOS inverter. So this one is PMOS and this one is NMOS. So this is VCC. So VCC is given from here. It is 5 volt, almost 5 volt. And this one is ground. So it is connected to the ground. And this one is input. We will give input from 0 to 5 volt. And this is after this resistor, this is the output. However, I have taken the output voltage across this resistor and LED. So I have taken a wire here. So I have connected a voltmeter. So voltmeter is connected. So you can see the reading of the voltmeter is 4.6, almost 5 volt. So this one is input, this one is output. So like this point, and this point. So I have already varied the input voltage from 0 to 5 volt, 0 to 5 volt, and I got this table. When the input voltage is 0 volt, so output voltage I get on the in the voltmeter is 4.9 volt. At 1 volt it is decreasing. So at some point at the around 2.4 or 2.5, the output voltage is pulled to 0. Okay, so further you will increase the input voltage, you will get 0. So a graph you will get something like this. Okay, so this is the graph of CMOS inverter. So you give 1, I mean logic 1, so you'll get 0, output 0. So this is logic 1 input, and if you will give input V in as logic 0, so you will get output as logic 1, which is maybe 5 volt. So I'm going to show you when I increase this input, so your output, which is this, will start decreasing. You can see further I increase, the output is pulled to 0. Okay, so you can see this LED is glowing now, input LED, and output LED is stopped. Okay, so if I again decrease my input voltage to 0, okay, you can see the input LED is shut off and output LED starts glowing. Okay, so this is the function of CMOS inverter. So you give logic 1, you in output you will get logic 0, and if you will give logic 0 input, and at the output you will get logic 1. So to show you this more clearly, I have connected input with the help of function generator, and in the function generator I have taken 1 Hertz square wave. So 1 Hertz square wave I am giving to the input. So the input is something like this: 0 1 0 1 0 1. So at the input I have removed this constant voltage, and I am giving the input from the function generator, which is square wave. So as I connected here, so the square wave input is reflected here in complementary fashion. So this was all about CMOS inverter. So CMOS inverter logic is widely used in making our integrated circuits, chips, in mobile and computers chips. Also you will get this CMOS inverters, because CMOS inverter can make NAND gates, and you know that NAND gate is an universal gate, so you can make any digital circuit using the CMOS inverter. So this was all about CMOS inverter. Thank you.